Assalamu alaikum. Today we are going to do partial fractions P3, A2 and the code is 9709. Consider first a function such as f of x is identical to 2 over x plus 1 plus x over x squared plus 1. F of x may be expressed as a single fraction with a common denominator. Thus, f of x is identical to 2 over x plus 1 plus x over x squared plus 1. And this is identical to take the LCM. So you have to multiply 2 by x squared plus 1 and plus x into x plus 1 whole over x plus 1 times x squared plus 1. So if we simplify this, we get 3x squared plus x plus 2 over x plus 1 times x squared plus 1. It is often useful to be able to reverse this operation, that is, to take a function such as f of x is identical to x minus 2 over x plus 3 times x minus 4 and express f of x as a sum of two, or in some cases more, separate fractions. This process is called expressing or decomposing f of x in partial fractions. If the original fraction is proper, the partial fractions will also be proper. Thus, x minus 2 over x plus 3 times x plus 4 is identical to a over x plus 3 plus b over x plus 4. And x plus 3 over x minus 2 times x squared plus 4 is identical to a over x minus 2 plus bx plus c over x squared plus 4, where a, b and c are constant to be determined. Let's deal with four types of fractions. Number 1. Decompose x plus 3 over x minus 2 times x plus 4 into partial fractions. This example is a proper fraction with linear factors only, and so its partial fractions are also proper. Examples of proper fractions: 7 over 11, 9 over 17, 2 over 3. In proper fractions, numerator is smaller than the denominator. In the above algebraic example, there is x of degree 1 in the numerator, and when you multiply x with x in the denominator, you get x squared. So the fraction becomes a proper fraction, x over x squared. So let's solve it. X plus 3 over x minus 2 times x plus 4. This is identical to a over x minus 2 plus b over x plus 4. So x plus 3 over x minus 2 times x plus 4 is identical to, you take the LCM, you have to multiply a by x plus 4 plus b times x minus 2 whole over x minus 2 times x plus 4. As the denominators are obviously identical, numerators must also be identical. That is, x plus 3 is identical to a times x plus 4 plus b times x minus 2. Choose 2 for x to eliminate b. So 2 plus 3 equals a times 2 plus 4 plus b times 0. From here we get the value of a as 5 over 6. Now substitute minus 4 for x to eliminate a. So minus 4 plus 3 is equal to b times minus 4 minus 2. So from here b equals 1 by 6. Therefore, x plus 3 over x minus 2 times x plus 4 is identical to 5 over 6 times x minus 2 plus 1 over 6 times x plus 4. Number 2. Express x squared minus 3 over x minus 1 times x squared plus 1 in partial fractions. This example contains a quadratic factor in the denominator. Therefore, x squared minus 3 over x minus 1 times x squared plus 1 is identical to a over x minus 1 plus bx plus c over x squared plus 1. This gives us x squared minus 3 over x minus 1 times x square plus 1 is identical to, we have to take LCM here, so multiply a by x square plus 1 plus bx plus c times x minus 1 whole over x minus 1 times x square plus 1. Now take the numerator only. X square minus 3 is identical to a times x square plus 1 plus bx plus c times x minus 1. Substituting 1 for x to eliminate b and c gives 1 square minus 3 equals a times 1 square plus 1. So from here we get the value of a equals minus 1. There is no value which we can substitute for x to eliminate a. By substituting 0 for x, we'll eliminate b. So minus 3 equals a times 1 plus c times minus 1. So c is equal to 2. Any other value can now be substituted for x to find b. A small value being sensible, take x is equal to 2. So 2 square minus 3 equals a times 2 square plus 1 plus 2b plus c times 2 minus 1. So 1 equals 5a plus 2b plus c. As a equals negative 1 and c is equal to 2, so place their values, and from here we find the value of b, which is 2. Therefore, x square minus 3 over x minus 1 times x square plus 1 is identical to minus 1 over x minus 1 plus 2x plus 2 over x square plus 1. Number 3. Express x minus 1 over x plus 1 times x minus 2 whole square in partial fractions. As x minus 2 whole square is identical to x minus 2 times x minus 2, it is called a repeated factor. In general, any repeated factor of the form ax plus b whole square in a denominator will give rise to two partial fractions of the form a over ax plus b and b over ax plus b whole square. Similarly, a repeated factor ax plus b times 3 give rise to three partial fractions of the form a over ax plus b, b over ax plus b whole square, and c over ax plus b whole cube. Returning to original problem, we have x minus 1 over x plus 1 times x minus 2 whole square. This is identical to a over x plus 1 plus b over x minus 2 plus d over x minus 2 whole square. You can write c instead of d. Therefore, x minus 1 is identical to a times, we are taking LCM here, so a times x minus 2 whole square plus b times x plus 1 times x minus 2 plus d times x plus 1. Substitute x is equal to 2 gives 2 minus 1 equals a times 2 minus 2 whole square plus b times 2 plus 1 times 2 minus 2 plus d times 2 plus 1. So this gives us d, and which is 1 by 3. Substitute x is equal to negative 1 gives minus 1 equals a times minus 1 minus 2 whole square plus b times minus 1 plus 1 times minus 1 minus 2 plus d times minus 1 plus 1. So from here minus 2 equals a times minus 3 whole square, so a is equal to minus 2 over 9. Substitute any value of x, say x is equal to 1. So 1 minus 1 equals a times 1 minus 2 whole square plus b times 1 plus 1 times 1 minus 2 plus d times 1 plus 1. 0 equals minus 2 over 9, which was the value of a, times minus 1 whole square plus b times 2 times minus 1 plus d was 1 by 3 times 2. So 0 equals minus 2 over 9 minus 2b plus 2 over 3. From here, may isolate b, and you will get the value of b, which is 2 by 9. Therefore, x minus 1 over x plus 1 times x minus 2 whole square is identical to 2 over 9 times x plus 1 plus 2 over 9 times x minus 2 plus 1 over 3 x minus 2 whole square. Fourth one, express x cube over x plus 1 times x minus 3 in partial fractions. So this is an improper fraction, and it is necessary first to divide the denominator into the numerator to obtain a mixed fraction. So let's divide. X cube is inside and x square minus 2x minus 3 is outside. This x square minus 2x minus 3 came from the multiplication of x plus 1 times x minus 3. So we have to produce x power 3 from x square minus 2x minus 3. So we have to multiply this by x. So you people should focus on bringing the x power 3. So x square multiplied by x gives us x power 3, then minus 2x square minus 3x. So write x cube minus 2x square minus 3x under it and x on the top. Now change the sign. So x cube will cancel each other out. So you get 2x square plus 3x. Now you have to produce 2x square from x square minus 2x minus 3. So you have to multiply x square by 2 only. So you get 2x square minus 4x minus 6. So write it under it, and on the top write plus 2. So you get, after changing the sign, 2x square will cancel each other out, and the remainder would be 7x plus 6. Now the 7x plus 6 is smaller than the divisor, so x cube over x plus 1 times x minus 3 is identical to x plus 2 plus remainder over x minus 1 times x minus 3. So how we will write it here? X plus 2 plus a over x plus 1 plus b over x minus 3. Therefore x cube is identical to x plus 2 multiply x plus 1. By mistake I have written x minus 1 in the denominator, remainder over x minus 1, x minus 3, so you better correct it. Now x plus 2, x plus 1, x minus 3 will multiply, and plus a times x minus 3 plus b times x plus 1. So if we put value of x is equal to 3 in it, this gives us 3 power 3, 3 plus 2 times 3 plus 1, 3 minus 3, plus a times 3 minus 3 plus b times 3 plus 1. So 27 equals 4b, and from here the value of b is 27 by 4. Now x equals minus 1 gives minus 1 power 3 equals minus 1 plus 2 times minus 1 plus 1 times minus 1 minus 3 plus a times minus 1 minus 3 plus b times minus 1 plus 1. So by simplifying this, we get minus 1 equals minus 4a and a equals 1 by 4. Therefore x power 3 over x plus 1 times x minus 3 is identical to x plus 2 plus 1 over 4 x plus 1 plus 27 over 4 x minus 3. And that's it. These are the 4 partial fractions which are to be asked by the examiner. So try some questions for practice. X plus 10 over 2 minus x times 1 plus x square in partial fractions. Let me write its answer here. So your answer should be 2 over 2 minus x plus 2x plus 4 over 1 plus x square. One more question. X plus 2 minus x plus 8x square over 1 minus x times 1 plus 2x times 2 plus x. So in partial fraction, its answer should be 1 over 1 minus x plus 2 over 1 plus 2x minus 4 over 2 plus x. That's it, my students. Thank you so much.